For millions of years, it drifted through the galaxy in near silence. Until now. This isn't a comet like any other. This is an interstellar visitor, an object born in a star system far beyond our own. And now, it's waking up. Astronomers first spotted 3I/ATLAS earlier in 2025. Positioned on a hyperbolic path far too fast and too steep to be bound by our sun, it was immediately flagged as only the third interstellar object ever recorded. But what has shocked scientists in the last few weeks is something far more dramatic. A colossal jet of gas and dust erupting from 3I/ATLAS and shooting directly toward the sun. Comets are known for spewing jets. That's how they form their glowing tails. But not like this. The scale, direction, and precision of this jet defy normal behavior. Astronomers describe a fan-shaped blast extending thousands of kilometers from the comet's nucleus, angled sunward rather than trailing behind. As 3I/ATLAS plunges toward its closest approach, telescopes across the world are locked on. Some researchers say we're witnessing the most extraordinary natural event of the decade. Others quietly wonder if we're seeing something else entirely. A signal of design rather than chance. A visitor older than the sun. 3I/ATLAS appears to come from the Milky Way's thick stellar disk, meaning it could be older than our entire solar system, perhaps 7 billion years or more. That gives it unimaginable time to travel, to freeze, to transform. Once it entered our system, sunlight began to heat its frozen surface. Instead of releasing gas evenly, however, it erupted in a single focused jet aimed at the star. At Spain's Teide Observatory, astronomers stacked dozens of long exposure images revealing a bright fan-shaped plume pointing sunward. Why would a comet push material toward the sun? Normally, solar radiation pushes particles away, creating a tail that streams outward. But 3I/ATLAS appears to be doing the opposite, a violation of everything we know about comet dynamics. Some scientists still believe it's natural, perhaps an unusual vent geometry or internal cavity directing the outflow. Others argue the alignment and force are too perfect to be coincidence, the chemistry that shouldn't exist. Spectral readings from multiple observatories show a coma rich in carbon dioxide, water, and carbon monoxide, but in ratios unseen in typical comets. The CO2 content is several times higher than anything orbiting our sun. Its polarization readings are also unlike any known body, suggesting either a unique composition or an artificial surface texture. The simplest explanation, 3I/ATLAS was born in an environment completely different from ours. The more controversial one, it was built there. Because the sunward jet implies directional energy release, as if internal chambers or mechanisms are focusing pressure. If this were an ordinary chunk of ice, that precision shouldn't exist. And the timing just before perihelion makes it look almost deliberate, like something reactivating after a long sleep. Natural phenomenon or encoded intent. If 3I/ATLAS were merely rock and ice, it would still be priceless to science. But what if the pattern of its activity suggests something else? A system reacting to the sun on purpose. Some researchers now compare it to the interstellar object Oumuamua, which displayed unexplained acceleration in 2017. Both are hyperbolic, both are non-gravitationally active, and both appeared to wake up as they neared the sun. If a civilization ever wanted to send a probe through other star systems, using natural cometary materials as camouflage would be the perfect strategy. Of course, mainstream astronomy still favors caution. Extraordinary claims require extraordinary evidence, and most physicists maintain that 3I/ATLAS is a natural interstellar comet. But the data are strange enough that even conservative voices admit it doesn't behave the way comets are supposed to. A worldwide race to watch history. Across the globe, observatories are tracking every flicker and color change. From Chile's Very Large Telescope to NASA's Hubble and Webb, to amateur astronomers running backyard rigs. Everyone is trying to capture the moment. Reports describe the comet turning green, a telltale sign of cyanogen gas reacting to sunlight. Yet even that glow appears unusually intense. What we're witnessing is the first detailed look at an object from another star system undergoing active transformation near our own sun. It's a once-in-a-lifetime scientific event, and a philosophical one. For the first time, the cosmos is not a distant question. It's performing right in front of us. Imagine standing under a night sky and realizing that faint point of light isn't one of ours. It traveled for billions of years through interstellar space, carrying chemistry and secrets from a place no human will ever see. And now, as it passes through our solar system, it erupts, a jet of material shooting straight at the heart of the sun, as though acknowledging its presence. Is that physics or intention? If it's purely mechanical, the universe just gave us a show of impossible beauty. If it's more than that, then something across the galaxy just blinked, and we happened to be watching. As 3I/ATLAS continues its journey toward perihelion, one truth is already certain. This object is rewriting how we understand the space between stars. Whether it's an ancient comet, an alien probe, or something we haven't yet imagined, its behavior demands attention. Because every time the universe sends us a visitor like this, it's offering an invitation to look closer, to question more deeply, and to remember how little we truly know. So here's the question left, hanging over every telescope lens tonight. Are we simply studying a rock, or are we being studied back? Either way, the silence of space just got a little louder, and it may never be quiet again. When NASA released the newest composite images of 3I/ATLAS, the world took a collective breath. What looked like a distant speck in early frames now stretched into a dynamic, glowing structure. A comet that wasn't simply passing through, but reacting in real time. The jet wasn't random. Across multiple frames, it pulsed, brightened, and seemed to flicker at precise intervals. Some observers described it like a heartbeat, a rhythm measured not in seconds, but in light. If that sounds poetic, the scientists staring at the raw data didn't think so. At the Jet Propulsion Laboratory, analysts noticed something subtle. The outflow repeated in nearly uniform cycles. Every burst of gas and dust came roughly 14 hours apart, as if governed by a consistent rotational period. That may sound ordinary for a comet, but not for one traveling from beyond the solar system, heated unevenly and subjected to forces no model can quite predict. It was as if 3I/ATLAS wasn't improvising. It was following a plan, the Global Telescope Network. Within days, the European Space Agency coordinated what it called a distributed observation chain. From Chile's Atacama Desert to Hawaii's Mauna Kea and Japan's Subaru Telescope, data flowed around the clock. The goal: measure composition, jet velocity, and light curve amplitude before the comet sweeps past the sun. This was unprecedented cooperation. A worldwide campaign tracking a single object of interstellar origin in real time. Even the International Asteroid Warning Network, usually focused on planetary defense, joined in. They weren't afraid of an impact. 3I/ATLAS would never come close enough for that. They were afraid of ignorance, of missing something that could redefine cosmic science forever. Every night, observatories shared spectra across encrypted channels. The results: intensities of carbon dioxide gas beyond predicted values, fluctuating dust densities, and microjets that seem to originate from beneath the main surface layer. Whatever 3I/ATLAS was, it wasn't frozen solid. It was alive with energy. A lesson from the sun. When the jet first appeared, astrophysicists assumed solar wind caused it. But then came the surprise. The emission didn't blow away from the sun. It aligned toward it, against radiation pressure. To resist that force, the gas had to be expelled at extraordinary velocity, nearly 700 meters per second. That's not unheard of, but it's rare, and for a body this old, nearly impossible. Some researchers proposed that magnetic interactions were guiding the jet. Others suspected an electrostatic effect, the comet's crust charging as it entered stronger solar fields, then discharging violently. Either way, 3I/ATLAS seemed to understand its environment better than our equations did. Every burst turned solar particles into light, creating ripples across its coma like shockwaves on water. For a few fleeting seconds after each flare, the comet glowed almost sentiently, a pulse from another star system, echoing in our own. Theories. Divide the debate over three, I/ATLAS. Split the astronomical community. Camp 1. The naturalists. They see it as a fossil from another sun, a sample of cosmic chemistry carrying new isotopic ratios, a record of formation conditions billions of years before ours. Its behavior, though dramatic, is still physics: heat, spin, pressure, release. Camp 2. The unconventional thinkers. They see the precision of its cycles, the direction of its jet, and its hyperbolic trajectory as potential evidence of control. Not a spaceship in the Hollywood sense, but a self-regulating messenger, a probe disguised as rock and ice. It's worth remembering, the first interstellar visitor, Oumuamua, also confounded expectations. It didn't shine like a comet, yet it accelerated mysteriously. Harvard astrophysicist Avi Loeb famously suggested it could be alien technology using light sail propulsion. Now, only a few years later, another object from beyond behaves unpredictably, but this time under everyone's watch. Coincidence or pattern? Planetary Defense gets involved. As 3I/ATLAS brightened, the International Asteroid Warning Network initiated continuous tracking, partly for science, partly for safety. Whenever something from interstellar space approaches the inner solar system, gravitational uncertainties make trajectories tricky. Even a 1 in a million deviation could shift predictions. For the first time, NASA's Planetary Defense Coordination Office teamed up with ESA's Near-Earth Object Mission Team to cross-check orbit data in real time. They wanted to know whether this object's energy release could alter its path in unexpected ways. The results? So far, no threat. But minor course shifts have been recorded. Each time a jet fired, the comet's velocity changed by measurable amounts, implying thrust, tiny but consistent. In engineering terms, that's propulsion. And that's why, quietly, some within the defense community began using a different term for 3I/ATLAS. They stopped calling it a comet. They started calling it a system. The public awakens. The new images lit up social media. Videos comparing 3I/ATLAS to a cosmic volcano reached millions overnight. Hashtags like #AlienComet and #InterstellarVisitor trended globally. For the first time in years, the public was looking up, not in fear, but fascination. Schools streamed telescope feeds in classrooms. Evening news anchors pronounced its name with growing confidence. 3I/ATLAS. It became a symbol of wonder, proof that the universe still has surprises left. And maybe that's the real legacy of this object. It reminded us that space isn't empty. It's alive, dynamic, and still capable of humbling us. A message in motion. By late October, as the comet neared perihelion, its jet stabilized into a constant sunward stream. Spectrographic data showed repeating spikes at specific wavelengths, almost like a signal pattern. The mainstream explanation, rotational modulation. The fringe interpretation, communication. If the jet truly follows timed cycles, it could encode information, a pattern of bursts readable as data. That idea remains speculative, but it has sparked a new discipline some call astrolinguistics, the search for meaning in cosmic phenomena. Is it nonsense? Maybe. But every breakthrough starts as heresy, because once, the idea that rocks could fall from the sky was heresy too. So was the idea that Earth moves around the sun. Now we face a new question. What if something from another star system just said hello? And we almost missed it. The next chapter. Within months, 3I/ATLAS will slingshot out of our system forever, vanishing into deep space. We may never see it again, but the data it leaves behind could occupy scientists for decades. Each pulse, each dust sample, each isotope ratio will rewrite our understanding of interstellar matter, and maybe intelligence. The European Space Agency plans to archive every observation in an open database by early 2026, and NASA has already proposed a theoretical Rapid Intercept Mission template, a design for the next time an interstellar object appears. Because now that we know they come, we want to be ready. The meaning of the jet. Whether natural or not, the symbolism is impossible to ignore. A traveler from another star arrives in silence, approaches our sun, then fires a jet of light toward it. A salute, a challenge, or perhaps just physics. Either way, it feels personal. The sun has always been humanity's oldest deity, the light that gave us life. Now, an interstellar visitor kneels before it, releasing energy back into the same star that created us. It's cosmic symmetry. It's poetry written in plasma. And somewhere out there, perhaps around another star, someone might be watching their own sky, seeing a tiny speck of light that once belonged to us, wondering the same thing we are now. Are we alone? Or are we all just travelers crossing paths in the endless dark? If 3I/ATLAS truly came from another world, it carried with it the chemistry, memory, and mystery of that place. Now, as it fades beyond reach, it leaves us with one final gift. A reminder that discovery doesn't just happen in laboratories or observatories. It happens when curiosity overcomes fear. It happens when we dare to look up. Because somewhere, light years away, another civilization might be watching their own visitor ignite, and asking the same question we are tonight. What wakes up the universe when it looks back at itself?